Good morning, everyone, and welcome to what probably is our last lecture this semester. Last in terms of the concepts, or last in terms of the lessons, but we will keep doing practice in the remaining lectures. But probably this is going to be the last topic this semester: correlation. Just to explain what we mean by correlation and how it's different from other inferential statistical tests. I think this would be enough for everyone, this term. I'll probably continue recording lectures just to put them on YouTube for references for those who want to, just for guidance for those who will engage in quantitative research in the second semester. But correlation probably is the last topic we will tackle this semester. I was hoping we can do more things on effects size and multiple regression and regression models and stuff like that, but um, apparently some of you are not really ready for that. But I decided to put a stop with this lecture 8. I think that's enough for you, given your background and given the nature of this module, um, which still I think is necessary to communicate, to effectively and systematically communicate results and findings in applied linguistics research. So today we're going to talk about correlation, how it's different from other inferential statistical tests, the types of correlational tests. We're going to see examples of them being calculated manually, um, and then probably later we can see how we can do them in SPSS or in Excel. So first, I just want, as usual, to give you a reminder about the homeworks, online homeworks. There probably will be a third homework that is that will be just in a form of revision for everything we've done this semester. But just keep in mind that all of the two homeworks are open until the 16th of December. So even those who missed the deadline, who could not access and could not do the quiz before, you may log in to Moodle again and do your homework. All of the homeworks are open until the 16th of December, after which they will be permanently closed because I will have to give you your TD marks. All right. So the 16th of December is the last chance. Also, for those who could not access Moodle because of a problem with their email or their password or something like that, I also opened self-access mode. Self-access mode meaning you can register and do your homework by logging in with your um, with your username and with your own password or your own email. But please, please, please use your real name. Okay, use your real name. Don't use a pseudonym. You can use always with professional things, with professional matters, academic matters. Use your real name. Okay, you never know. You never know what's gonna happen. Always use your real name. If you're on Facebook, I understand. You can use your pseudonym or on social media, but when it comes to things like this, please use your real name. All right. Uh, because it was brought to my attention that you've been under a lot of pressure, and I understand the third semester in a master's degree is really quite intensive in terms of the amount of work you have been doing. So all of the homeworks will be open until the 16th of December. All right. So, all right. Today we're going to talk about correlation, and probably uh, we should go, before we start talking about correlation, let's go back one step and remember the two main types of advanced tests. So we did not divide them like this, but when I gave you the table, if you remember this table here, uh, we classified inferential statistics based on parametric, non-parametric tests, them being parametric like the paired t-test and the independent t-test, and their equivalent non-parametric tests, the Wilcoxon ranked sum test and the Mann-Whitney U test. And we saw two main categories of tests. Tests that assess the difference, the significance in terms of difference, and the last two tests comparing or seeing the relationship between the two variables. Now, when we look at, for example, tests that compare between two data sets, they can either compare between paired groups or like the pre-test, post-test design, or between independent groups like the experimental group and control group design. They can either also compare the difference between three tests or between three groups like experimental group 1, experimental group 2, and the control groups like the ANOVA test and the Kruskal-Wallis test. On the other hand, we can also see the difference between three tests for a paired sample like a pre-test, post-test, and a delayed post-test, or test 1, test 2, test 3. So these tests assess the difference, okay? They assess the difference between the scores, okay? We want to see whether students' score in the post-test is significantly different from the pre-test. And we also want to see if the scores of the experimental group are significantly different from the control group. The same here, we want to see if the experimental group is significantly different from experimental group 2, or if it's significantly different from the control group. Also, we want to see in the paired samples for tests that want to compare between more than two tests, like the repeated measures ANOVA, we want to see if the pre-test or the post-test 2 is significantly different from post-test 1 and pre-test. So in these tests here, we want to see the difference, okay, the difference. But in the last two tests, there was no picture here because those tests, the Pearson correlation R and the Spearman correlation, they measure the correlation or relationship between two sets of data. For example, testing the relationship between classroom attendance and oral expression exam results. We want to see the relationship between these two variables, all right? So this is why I put this here. So advanced statistical tests or inferential statistical tests, we have two types. They can either assess the difference or they can assess the relationship between two variables. Now, the concept of correlation. So we're going to start with some definitions and then move to more practical things. The concept of correlation refers to statistical tests that investigate the degree to which two or more variables are linked to each other, okay? So to what extent are two variables linked to each other? For example, a correlational study in applied linguistics would look at the relationship between the number of years living abroad and learners' pronunciation accuracy, for example. Is it the more we live abroad, our pronunciation gets better or not? So we want to see if there is a linear relationship, okay? علاقة خطية. If we want to see if there is a linear relationship between living abroad and improving pronunciation, okay? So we can do this through inferential statistical tests. Now, the procedure to do this is called correlation analysis. And in correlational studies, they don't always have to be experimental. Like, for example, the tests we've seen here, there should be some kind of treatment. There should be some kind of an experiment, a pre-test and post-test, and so on. In correlational studies, we don't really need an experiment. We can do an experiment to compare and to correlate between two variables, but we can do this without even doing an experiment, okay? We can just ask people, we give them a questionnaire and ask them about the number of years they've been living abroad, they will report it, and then we do a test on pronunciation without resorting to an experiment. We give them a simple task to complete, simple pronunciation tasks. So we don't really need to conduct an experiment. Many correlational studies are non-experimental. There could be, we can do correlational analysis after an experiment, but it's not necessary. So, yeah. I think this one was repeated. So, but an important thing to always remember is that what correlational studies give us is just a linear relationship. They just shed the light on a linear relationship between two variables, all right? They are not telling us if the variables are causing each other. They are not telling us a causal relationship, okay? So correlational research, as McKay and Gass said, correlational research attempts to determine the relationship between or among variables. It does not determine causation. It does not determine causation. What determines causation is an experiment, okay? A quasi-experimental study where we do a treatment and see if that treatment causes an effect or not. In correlational research, we're only looking if the two variables are linked or not. They are linked or not. We will see how is that different, okay, with an example. So, for example, I gave an example here in your handout. You might find it in your handouts, or you will find it in your handout. Just because British people spend more money in shops during the winter, it does not mean that the cold temperature is causing people in the UK to spend more. It just happened that the winter season coincides with the British holiday season, a period that is known for increased spending. So, not because just British people are spending more money in the winter, it doesn't mean that the winter or the cold winter is what's causing the spending or the increased spending. It just coincides that winter is a month where or the month or the season for, or the holiday season for the British people, and that's why they spend more time. It's like Ramadan in our culture. So this is why we always say be careful. Correlation does not always mean causation. I think that I should put it this way. Okay, so correlation does not always mean causation, and this is important. Okay, this is important. Why is it important? Because it's important for those who do correlational studies to not overinterpret their findings. Okay, we don't want you to it does not so Ayub, just bear with me and let me finish. You'll see examples and I will explain what I mean by this. Okay, you can do a correlational study without an experiment and you can find the relationship, but it does not necessarily mean that it is that one variable is causing the other. All right, sometimes it implies that, sometimes yes, sometimes, but correlation does not always mean causation, does not always mean causation. And we go back we go back to the example that we started with this year in the very first lecture. So we have a correlation between ice cream sales and sunburns. If we do a study on ice cream sales in the summer and sunburns, we will find that both are correlated, highly correlated, meaning that ice cream sales happen at the same time or increase at the same time that sunburns increase. It does not mean that ice cream sales are causing sunburns. And also, it does not mean that sunburns are causing ice cream sales. It's just happened that they both happen. They have a third cause. That is the dry, hot, and sunny summer weather. All right? Why I was saying that correlation does not always mean causation, because the things that the variables that you found correlated, they could be, there is a chance that they may be causing each other, but maybe also there is a chance that there is a third cause that you did not account for. Okay, so we always should be careful when interpreting correlation results because they don't always mean causation. And this is something that, or a warning I start with, because correlational research is fun and we can have a lot of ideas when we are doing this research, and especially we can be very, very happy when we find a relationship, because it's very difficult to find a relationship in research, and when we find a relationship, we're always happy to report it and say, yeah, I found a relationship. I found there is a relationship between classroom attendance and exams and exam results. Okay, perhaps there is a relationship, but perhaps there is also a cause. So we should be careful when we interpret these results in the results section or the discussion, and we shouldn't overinterpret our results. I mean, we shouldn't overinterpret any results, because it's always important to be careful and to be uh, realistic with your results. All right. So now let's talk about detecting a correlation. Let's start with the descriptive statistics. Okay, we can detect correlations in descriptive research. We can actually do this. Some of you might think how, and we'll see an example. Uh, so because we're trying to find a relationship between variables, sometimes we can do this with simple measures of frequency or percentages. Here we have percentages of public library members by their social class origin. Okay, we have the public library membership, a member, a non-member, a total. We have the social class status. Now this is a British example. The middle class is really, for us in Algeria, middle class is really the high class, and working class is, I think, what they call in the US as the blue collar, or the jobs done by hand, the working class, the plumbers, the carpenters, the people who work with their hands. And the middle class is kind of sort of the higher class, the people who do desk jobs and are in the knowledge industry. Okay, so the middle class is higher than the working class. These are British terms. Okay, these are British terms. So working class is kind of a little bit of a low class. When a British person says that I'm from a working class, meaning they are from a humble family, it's not really a rich class. And if they say I'm from a middle class, they mean that they are from a well-off family who can afford most things. All right, and we can see percentages. Okay, so we can see that 80 or 86% of the middle class population are members of the public library membership. They are members, meaning they have membership, or they are subscribed to a library, because in the UK you can subscribe to libraries and you can go to those libraries and read books and borrow books from public libraries. And only 14% of the middle class are non-members. Okay, they are not members of the library. On the other hand, we find that only 37% of working class population are members of the public library. On the other hand, 63% of the working class are non-members, meaning we have higher percentage of working class who are non-members than members, right? Compared to the middle class. Now we can see that there is a pattern here. Why? Because we can see that middle class, or sorry, we can see that there is a relationship between class and affording things such as uh, public library memberships, okay, which might be for working class people as a secondary thing, because they are working hard to afford other things that are more important to them than a public library. And we can see that the class, or the social class status, is related to the membership, or being a member or non-member. Yeah, exactly. Yes, in this case it is the income. Okay, so we can see that there is a relationship. What we're focusing on here, Ayub, uh, is being a member is related to your social status. If you're from the middle class, or if you're from a higher class, you're more likely to be a member of the library. If you're from a lower class, you're more or less likely to be a member. Exactly, yes. Abir Khalfa. Yes, exactly. So there is a relationship here between just from descriptive statistics, you can do this in your study. It doesn't have to go through advanced statistical tests. You can show or you can highlight correlations just by simple measures of frequency or simple measures of or percentages. So here, just from reading or looking at this table, we can see there is a relationship between class or social class status and being a member of a public library. Now, when we move to inferential statistical tests, we said that we have two inferential statistical tests. We have the Pearson correlation and we have the Spearman's correlation. The Pearson correlation is the parametric correlation test, is the parametric test, and the Spearman correlation is non-parametric equivalence, all right? Meaning that ideally, I always say ideally, for the Pearson correlation to be conducted, we usually need numerical data, random sampling, normal distribution of data, and homogeneous variances, okay? Especially normal distribution of data. We need it for Pearson correlation. It's very sensitive. If we don't meet any of those assumptions, the Spearman correlation can work with categorical data, can work with non-random sampling, and can work with non-normal distribution of data, and also can work with heterogeneous variances, all right? So you might have numerical data, you might have random sampling, but unfortunately, when you do your when you plot the results in a histogram, you find that you have a non-normal distribution of data, and therefore you have to resort into the Spearman correlation despite having numerical data and random sampling, because you violated one of the assumptions. As we said, that if you violate any of the assumptions, we should immediately resort to the non-parametric correlation test. This does not mean that your results will not be reliable with the Spearman's correlation. They will be. It's just that it is better to use the Spearman's correlation because it will compensate for any of the problems in your data. It will compensate, okay? It will give you a more realistic results than if you were to use the Pearson correlation, because if you violate one of the assumptions and still use the Pearson correlation, you might end up with a false positive. You might end up with the completely misleading results, okay? Completely misleading results. So these are the two tests in correlation. These are the only two tests we have in correlation. Not the only ones, there are others, but these are the most widely used, okay? The parametric and non-parametric equivalence. Now we have the correlational tests are designed to answer the following questions. Is there a relationship between two or more variables? Is there a relationship between two or more variables? What is the direction of the relationship? And what is the strength of the relationship? All right. So we're interested in three questions. Is there a relationship? What is the direction of the relationship? Is it positive or negative? And what is the strength of the relationship? And we're going to see exactly what we mean by that. So the direction of the relationship could either be positive or negative, okay? So it could either be a positive correlation or a negative correlation. Correlations reflecting this pattern, or positive correlations, positive correlations are prefaced with a plus sign to indicate the positive nature. Okay? A positive correlation means that whenever one variable increases, the other increases. The more you spend years in England, the better your pronunciation will be. Okay? The more you spend time in the UK, the better your pronunciation will be, or the better your pronunciation score will be. All right. On the other hand, a negative correlation, always indicated with a negative sign, is to be found when an increase in one variable is accompanied by a decrease in the other. The more you use your phone in the classroom, the less your attention will be, right? The more you use your phone in the classroom, the lesser your attention will be, all right? So this is what we mean by negative relationship, okay? So in a positive relationship, we'll find an increase in both variables. And in a negative relationship, the more one variable increases, the other decreases. And we'll see examples. Okay, we'll see examples. Just wait. Right? Now we have different strengths of a correlation. A correlation test can give us no correlation, low correlation, medium correlation, strong correlation, perfect correlation. Although this in social sciences is really rarely, if never found. Okay? Rarely found. Okay? You can see here from Cohen, 2007, Cohen et al., 2007. However, perfect correlation, perfect positive correlation, or perfect negative correlation, or even zero, no correlation, are rarely found, and most coefficients of correlation in social research are around the area of 0.50 or less. Okay, we'll see exactly the scale. What I want to say is that no correlation, perfect no correlation of 0, or perfect correlation of +1 or -1 are rarely found, rarely or never found in social research, in the humanities and social sciences. Okay, we might find them in nature, we find them in physics and biology, but in social sciences, as always, we're dealing with unpredictable humans, and therefore it is really rarely found. Okay. So the strength of a relationship is measured with this scale. So we have 0, meaning no correlation. You can see here, 0, no correlation at all. You will see that the dots will be all over the place. We can have perfect positive correlation, where there is a positive sign and 1, positive sign and 1. And we have perfect linear relationship, علاقة خطية, perfect علاقة خطية. Okay. On the other hand, a perfect negative correlation, we have a perfect linear negative correlation, which will usually indicated in the tests when we conduct the Spearman or the Pearson correlation. We'll find -1.0. Okay, this is what we will find if we do the test and find the perfect negative correlation. But we already established that perfect does not exist in social sciences. We usually find this, the medium negative correlation or the medium positive correlation. All right, we usually find this. And usually when we find, for example, medium positive correlation, we find this sort of plots, okay, with a result that looks like this, plus 0.5, okay, plus 0.5. And we said that in statistics, when there is a 0 before the decimal, we usually don't write that 0, we just ignore it, and we write 0.5, 0.5. This is a medium positive correlation. On the other hand, a medium negative correlation is usually found with a number like this, -0.7, -0.7. Okay, this is a medium. I would say even if we were doing the Spearman correlation, I would say this is a high negative correlation, a high negative correlation. This is an important graph. Remember this. Remember this. Okay, this is an important graph because it is showing you all of the possible results. When we conduct the Pearson correlation and the Spearman correlation later, we'll find these results. We'll find these results. Okay. Now you might see this and wonder, what is this? Why are we plotting the results like this? I'll probably need to do a simple demonstration. The scatter plot, Ayub. Yes, exactly. The scatter plots. Let me see. Let me see. Or I think we will find those. We'll explain those plots later. Okay. We usually plot something with one variable on the x-axis and one variable on the y-axis. This is important in statistics, something we did a lot back in the day in mathematics. Okay, the x-axis always horizontal and the vertical axis is the y-axis, and we plot our results on those axes. Okay, but we will see those plots and we will see those examples. So now let's move to the Pearson correlation. Okay, the Pearson product moment correlation. This is the full official name, but I usually prefer to, or in statistics in general, we prefer to call it the Pearson correlation. Just the Pearson correlation is enough. So we call it the Pearson product moment correlation is the standard type computed between two continuous variables. When we talk about correlation in general, this is what we usually mean. The Pearson product moment correlation coefficient is symbolized by the lowercase r. Okay, when we look for the Pearson correlation, we usually نرمز لها بالحرف R. Okay, R. The symbol R for the Pearson correlation. Okay, you will usually see this Pearson correlation R. Okay, and this is this test is the product is brought to you by Karl Pearson, the English mathematician and statistician. He is English. I think he worked in the University College London. There is a funny thing I will tell you later about this guy, and he brought us this formula to calculate the correlation, Pearson correlation. So this is the formula that we need to calculate the correlation. It looks intimidating, and it looks like it's from another planet, but believe me, this is straightforward, and I will explain how. Let's see an example data set to calculate the Pearson correlation form. Okay, let's say you are conducting a study about the language learning experience, the relationship between the language learning experience and grammatical errors among EFL learners. What do we mean by language learning experience? Language learning experience is usually a technical term used in research to refer to the number of years a person has been learning a foreign or a second language, or second or a foreign language. Okay. For example, most of you at university level, you usually have a language learning experience of 9 to 12 years, depending on your age, depending on your background, it doesn't matter. Okay. Meaning you've been learning English for 9 years, at least 9 years since high school, since middle school, because at your time you didn't have English in your primary school. We refer to this as language learning experience. So 9 here just means years. You've been learning English for 9 years. So student 1 has been learning English for 9 years. Student 2 has been learning English for 12 years, and so on. And let's say we did an oral test with them to count the number of grammatical errors. The grammatical errors they commit, okay? Or in writing, let's say we gave them a paragraph and we told them to write a paragraph about a particular topic, and we counted the number of grammatical errors they make, okay? So student 1 made 37 errors, and this is a simple data set. This is what, when I say a data set, this is what I mean, okay? This is what I mean, a data set, your data. Let's say your study was conducted with 8 participants, okay? 8 participants, and we have the data. I think this is clear, okay? I think this is clear. Now, we see that the Pearson correlation formula is asking us for the sum of the x differences from the mean and the sum of multiplied by the sum of the y differences from the mean. What they're referring to as x and y is this. Language learning experience here is the x variable. It's just that the x variable, we're referring to this variable, language learning experience, as x, and grammatical errors, we're referring to them as y. رمزناهم برك. Yeah, I don't know if that's the correct term in Arabic, or if that's the correct in terms of mathematics for those with a scientific background. Okay, we just give them a sign or give them a symbol, x and y, because that's how we plot them on a scatter plot. Okay, so language learning experience X and um, and grammatical errors Y. And in order to find the differences of each value from the mean, we have to calculate the mean. Okay, we have to calculate the mean. See? So this is just, sorry, in Arabic was just doing this last night just to avoid any miscommunication. As we said, عدد سنوات تعلم لغة أجنبية أخطاء لغوية. Okay, when I say here we want to calculate the mean, the first thing we need to do to calculate the mean is that we have to calculate the sum. Okay, we have to calculate the sum. So مجموع قيم x, مجموع قيم x, when we calculate the sum here for x, and then we calculate the مجموع قيم y, and then we calculate the average. Okay, the average or the mean. The mean for a sample is x bar. Okay, the mean for a sample is x bar. This is why we're using x bar and y bar. Y bar is also just referring to the mean of y, the y values. Okay, the y values. So as a first step, we calculate the sum, which is 74 for language learning experience, and then we calculate the mean, which is 74 divided by 8 will give us 9.25. And then we calculate the sum for grammatical errors, which is 255, and we divide it by 8 because we have 8 observations or 8 participants, and it will give us an average of 31, meaning that the average person in our sample has spent 9.25 years learning a second language, learning a foreign language, and they on average make 31 errors. They on average make 31 errors. Since we have this, now we can start calculating for the first part of the formula. The first part of the formula is saying that it wants us to calculate the sum of the x differences from the mean, from their mean, which is x bar, multiplied by the y differences from their mean, which is the y bar. Okay, so let's go back. And to do this, we calculate this here. نبدأ كل قيمة نقصها من المعدل. 9 minus 9.25, 12 minus 9.25, and so on. We do the same here. 37 minus 31.88, 8 minus 31.88, and we get these results. 9 ناقص 9.25 تساوي ناقص 0.25. 12 ناقص 9.25 تعطينا 2.75 and so on. The differences from the mean. هذا وش قصدنا بالفوارق من المعدل. The same here, the y values divide or minus the mean, or the differences from the mean. We do the same. 37 minus 31.88. 37 ناقص 5 ناقص 37 ناقص 31.88 تعطينا 5.12 and so on. And we do the rest. Now to complete this, because the formula is telling us I need to multiply each difference for each student. For each student, the difference from the mean multiplied by the difference from the y, or the y differences from their mean. Meaning for each student, I have to multiply this value here with this value. Okay, I have to multiply those values. All right, I'll just highlight them in red. I'll have to multiply each value here, multiply them, and put them here, because this is the first part of the formula. This is the first part of the formula. The x differences from the mean multiplied by the y differences from the mean, from their mean. Okay, and when we do that, we get these results. وش درنا هنا؟ ضربنا ناقص 0.25 في 5.12 تعطينا 1.28. ضربنا 2.75 في ناقص 23.88 تعطينا ناقص 65.67. At the end, we add up all of these values. نجمعهم كامل الفاليوز هذو وتعطينا القيمة الأولى من الفورميلا اللي هي هذه. The sum of all our x differences from the mean multiplied by the y differences from the mean. That will give us this. Okay, minus 157.75. Okay, this is the first part of the formula. The second part of the formula is a little bit tricky. So we want to find the square root of the sum of the x differences from the mean squared multiplied by the sum of the y differences from their mean squared. Okay, meaning we have to square each difference from the mean, square them, square all of these differences from the mean. معناتها ناقص 0.25 أس 2. We just square it. We square this value here. And we do the same for the y differences from their mean. And we square them. That will give us those results. All right? That will give us those results here. So what we did here is minus 0.25 squared to the power of 2. And we get 0.06. The same squaring 2.75 and so on. But because the formula is telling us that I need the sum for each one, I need the sum of the x differences from the mean squared, and then also the sigma, or it is repeated here. So I need to calculate the sum for the y differences from their mean squared, meaning I have to do the same here. I have to do the same here. I have to square the y differences from their mean, all of the values for each student, and calculate the sum. Therefore, here we have all of the numbers we need. Okay, I'm just going to keep them in red. All of the numbers we need for the formula to work, for the Pearson correlation formula to work and get our results. Now what I'm going to do is I'm going to let you finish the work. Okay, so we have ناقص 157.75 as the first part of the formula. That is the sum of the x differences from the mean multiplied by the y differences from their mean. And we have the first value. And then divided by the square root of the sum of the x differences from the mean squared multiplied by the sum of the y differences from the mean squared. Okay, and the x differences from the mean squared, or the sum of the x differences from the mean, we already established. We squared all of the values. We squared all of them. We have 19.5 or 19.50. It's here. And for grammatical errors, we squared all of the differences from the mean. We found the results, and we added them. We added all of them up, and we have the final sum for the y differences from the mean squared is 1,430.88. It is here. Now I want you to finish the formula. I want you to finish the formula for me. I hope you've been following, and I hope this was not intimidating. I'm just gonna hide one thing. Yes. All right. I want you to finish the formula. Try to do it, whatever you're working on, and the first person to give me the results, or the first person to give me the results, is gonna get a gift. Not a gift, a reward. Is first, you're gonna make me really happy me see. I need to check my notes. I need to check my notes. Hayat Salim, you might want to reconsider. So close, yet so far. No, Sandis Filiali, no. Yes, Abir Khlelfa. Yes, you might want to round up that number. Yes, minus. It is negative. It is negative 0.94. Abir Khlelfa. Excellent. Hayat Salim, I would count that as correct. I don't know how you got a positive number. I don't know how you did it, but it is R equals 0.94. R equals 0.94. Yes, it's a negative, it's a high negative correlation. Also, Lilia, Aja Lilia, very good. Yes. But the first person to get it exactly correct is Abir Khlelfa. You might also want to round. I always keep 3 numbers. Don't leave a lot of numbers behind the decimal. Just leave 2 or 3 numbers maximum, because it will be confusing at some point and you start making mistakes. Always also round up just before the decimal. Let me show you the results here. So we have negative 0.94. Okay, so we multiply those numbers first, then we get 27,902.16, and then we square root this number and we get 167, and then we divide minus 157.75 by 167.04, and we get a high negative correlation. What does a high negative correlation? ناقص 0.94. High, very high negative correlation, I would even say. Okay, and this number is interpreted by this scale. You'll find this all over the internet. If you want the interpretation for the Pearson correlation results. So we have high correlation. So here, 0.90 or negative 0.90 is considered very high positive or negative correlation, as it goes both ways. And in this case, because we have 0.94 negative 0.94, it is very high negative correlation. Okay, yes, very high, not high. So this is wrong. Very high negative correlation. Very high negative correlation. Thankfully, we don't have to go all over this. We don't have to do this manually now, because we have SPSS and we have Excel, and it will show you how we can do this later in Excel. Okay, all of this actually. Let me just show you now. Let me just show you how we can do this in a new data set, so we don't confuse you. This is why we insist on using new technologies. Show you. I perhaps should have done this last night, but it's all right. Okay. You see here? All right, I'm gonna switch the window, just show you my Excel. Yes, so the same data set, the same results. So we have participants, language learning experience, grammatical errors, and when we conduct Pearson correlation, actually in SPSS, in Excel, it immediately calculates it immediately calculates the Pearson correlation. So what you have to do is just hit equal sign, just core, not even the entire word, the correlation coefficient, and you just select the results for language learning or the data for language learning experience, meaning the number of years students have been learning English. And then we select the grammatical errors, the second row, and we get these results. We get immediately the R equals, okay, let me just put it in 2 decimals. Yes, immediately get the results. See, all of that just for that. Okay, so you can just do it in seconds in Excel. This is why we insist Excel, SPSS, all of these programs, RStudio. These are time efficient software and programs that help you do way more analyses. Before, people used to do them manually, and they spend a lot of time doing these calculations, and one error or in rounding up or something like that, it gives you the wrong result. But now we have Excel. You can do this in a matter of seconds, right? So yeah, we will see how we do them, and also in SPSS, it's also very easy. It's just to analyze, correlate, choose Pearson or Spearman by just checking, and then you'll end up with your results in seconds. Okay, so thankfully we don't have to do the mess we're seeing, all of this mess here by manually calculating everything. All right. I want to show you how I also plotted the results. Okay, I plotted the results in this graph, this beautiful scatter plot. We call it a scatter plot. This is what we call a scatter plot. In the x-axis, we have the language learning experience. Let me just write here, years. So here we mean years, and grammatical errors, or number of grammatical errors. And we can see that, for example, this participant who spent 12 years learning English made probably 8 errors, okay? So, but this student here who spent maybe 7 years learning English, they made 55 errors, okay? So we can see just from the scatter plot, from this plot here, that the more we spend learning English, there is a relationship between the time we spend learning the target language and the number of errors we're making. Meaning, the more we spend learning English, the more time we spend learning English, the less likely we make errors. Meaning there is a negative relationship. Okay, it doesn't mean negative relationship in your mind. You might think this is something bad. It's not bad. It's not always bad. This is here. It's something good. The more we spend learning English, the less we make mistakes. And I'm going to show you how you can make the scatter plot. It's also very easy in Excel, in case you just don't know. All right. I'm going to show you how we can do this also. So the same, you don't have to draw the x-axis and the y-axis and all of that scatter plot. You just do this. You select the results. You select your results. And you just go quick analysis. If you don't have quick analysis, you just go insert, and you can find your charts here. Okay, you can choose the charts, and immediately you find the scatter plot. This is what we call a scatter plot, and immediately you have the scatter plot. You can add your axis titles, name them, grammar errors, or for example, you want to name them number of grammar errors if you want to be specific. And here, let's just say years learning English. And maybe you want to add the trend line showing that there is a trend toward a negative correlation. You can change the colors, and you can go crazy with the colors, with all of the info you have with Excel. It depends on the version of Excel you have, but you can do really many things and a lot of fun things. Okay, I can spend the entire day here. I can just customize, label the data if you want error bars, although we don't use error bars, the legend, yeah, whatever. I mean, you get the idea. You can find hundreds of tutorials on this stuff on YouTube, so there's no point of explaining this. Okay, so yes, up to this point, are we good? Are we good? Very good. Very nice. I know it might be a little confusing with manual calculations. To be honest, I never asked the students to do this on an exam up to this point to calculate the Pearson correlation manually. But it's important to see the background of these tests in SPSS and Excel, and uh, you know we just did the Pearson correlation in Excel in seconds. We just typed the code equal correlation, and it gave us the correlation coefficient. But it's important for I just for me. Okay, I'm curious to know what happened before we got this results here, this uh, this number here, the negative 94. Okay, I'm curious to know where this number come from. Okay, it came from a formula established by a statistician who went through all of the hustle just to calculate a relationship between two variables. And this is good. I think this is good. It gives you a wider perspective to what is happening in the background. It also gives you an idea why some tests in SPSS, when you give them the data set, they take sometimes some time to calculate, because sometimes they go through hundreds of calculations just to arrive at the final result. Okay. All right. Let's move to the Spearman correlation, and the Spearman correlation is the non-parametric equivalent for the Pearson correlation. As the name suggests, the correlation is based on the ranks of the data, or the order of the data, and I will explain what we mean by this. Okay. This test is used when the data of the variable being correlated do not meet the conditions for the parametric test. Okay, so whenever we don't meet the conditions for the parametric test, we immediately move to the Spearman correlation. The Spearman correlation is usually referred to as italic P, as an italic capital P, okay? Capital P, like this, okay? The Spearman correlation, all right? And the Spearman correlation is brought to you by this mind, Charles Edward Spearman, also an English statistician and mathematician, who was the colleague of Pearson, okay? Who was also the colleague of this guy we talked about, Karl Pearson, okay? And they actually did not get along. They really did not like each other a lot. Charles Edward, besides being a mathematician, by being a statistician, he was a psychologist. He was a researcher in psychology, and he made a lot of tests for psychology. Came up with a lot of tests and a lot of, if you will, solutions for statistics solution for psychology. But Karl Pearson did not like him a lot. Karl Pearson is coming from a mathematician background, and Pearson is coming from a psychologist, a psychology background. Okay, so they were actually both lecturers at University College London, or I think UCL, but they did not get along. Okay, the formula for the Spearman correlation is as follows: P equals 1 minus 6, 6 times the sum of the differences squared, divided by n here is for sample size multiplied by, between brackets, sample size squared minus 1. Now this, the first time you look at this formula and you think this is ridiculous. It looks obviously shorter, and it's actually easier than the Pearson correlation. If you want to calculate the Pearson correlation, you will have to do a lot of more work. Actually, the Spearman correlation, since your data violates one of the assumptions, which is of the parametric test, so this formula here is trying to compensate for that in a much more simple way. So to complete this formula, let's imagine that we have this data set, okay? Let's imagine that we have another data set, okay? In this data set, we have 8 participants, and we want to see the relationship between, yes, exactly, Ayub, clash of correlations, yes. It's funny because they came up with the 2 most widely used tests, yes. So the Spearman correlation here, for the Spearman correlation, let's see this data set. We have 8 participants, and we want to see the relationship between library use frequency, meaning the number of times students use the library per semester or per year, and their grammatical errors. We want to see if the more they use the library, whether they are going to read there. Maybe they read, they go read books, they improve, or maybe they just go and chat with their friends and eat and do fun stuff instead of reading. Okay, maybe we don't know. So we want to do a study on this. We want to correlate. We want to see the relationship between those 2 variables. Now, obviously, if you plot these results, you'll not find a normal distribution. And also, one other thing is that library use frequency here is probably collected using a questionnaire where we ask students how often do you use the library on a scale from 1 to 5, 1 being never and 5 maybe being always. Okay, so these data are categorical by nature because they are subjective, reported by students through a Likert scale, and so these results are already ordinal, and when we plot them, they're not really normally distributed, and therefore we resort to the Spearman correlation. Okay, we resorted here to the Spearman correlation. It's not the case for grammatical errors. Grammatical errors might be normally distributed. They're not really here normally distributed, but they are numerical. However, we already violated the assumptions, so we moved to the Spearman correlation. Okay, and for the Spearman correlation to work, we have to rank. Okay, we have to rank the values, meaning in Arabic نرتب القيم من الأكبر للأصغر، من الأكبر قيمة لأصغر قيمة. Let's do it. Okay, let's do this. Okay, here what I did is just organize the errors. Let's go just from maybe here. Let's start with these values. We order them from the biggest one to the lowest value. So maybe here 56, let's start with grammatical errors, is 1, it's the biggest value, and then we have 41, and then maybe 37, 3, and then we have 35, 4, 32, 5, 32, and then we have maybe, yes, we have 6, 24, 22, and 8 is 8. Okay, نظمنا القيم من أكبر قيمة لأصغر قيمة. Okay, 56 being the biggest value, it is ranked as the first value, and we have 8, which is the lowest value, so it is ranked 8, or the 8th value. ليش بديت انا بجراماتيكال ايرورز؟ لانه ما فيهاش قيم تتعاود، في قيمه ما تعاودت. المشكل هو هنا لانه عندنا قيم تتعاود. Let's go and rank library use frequency. 5 is the biggest value. 4 and then 4, it is only once, 4, so 2. But then we find 3. 3. So 3 repeated 3 times. We have a tie. عندنا تعادل تعقيم. When we have a tie, what we do is we add those numbers up and divide them. Okay, so we add the ranks. Normally what we would do if they were not tied, we would say 3, 4, and 5. But because they share the same value, okay, because they are tied, what we do is actually add up the ranks and divide them by 3. 3 زائد 4 زائد 5. 3 plus 4 plus 5 divided by 3. So their rank So if we go to a calculator, 3 plus 4 plus 5, it will give us 12 divided by 3, it will give us 4. So instead of 3, 4, 5, we give them all a rank of 4. Okay, a rank of 4, and this will be wrong. Okay, here I cannot erase it, but this will be wrong. Okay, and we would use 4 instead. Okay, 4 instead. Right, I hope this is clear, because we have a tie, 3, 3, 3. We don't add up the numbers themselves, 3, 3, 3. We add up the ranks. Normally, as I said, there will be a 3, 4, 5. But instead of doing that, because 3 and 3 and 3, they are tied. None of the values are bigger or smaller than each other. They are tied. And therefore, we add 3. We calculate an average for the ranks. 3 plus 4 plus 5 divided by 3, it gives us 4. Instead of 3, 4, 5, we give them all a rank of 4. And then we have also another tie, which is originally here to be 6 and 7. 6 and 7. Okay, watch carefully with me. Normally, if we continued the ranks, we would give these two a rank of 6 and 7. Okay, but that would be wrong, because why? They are tied. Okay, they are tied. What do we do because they are tied? What do we do here because they are tied? 6.5. Very good, Amani. Excellent. Yes, we give them a rank of 6.5. All right, 6.5. We rank them. This is why it's called the Spearman rank correlation. We are trying to compensate for the data not being numerical or not meeting the assumptions for parametric test by ranking those values. Okay, we're trying to give them a true numerical value. Okay, we're trying to give them a true numerical value. And the last one is 8. We continue from the last rank. Okay, we don't use 7 because 7 should have been used, but it is no longer used. Okay, it's no longer used, and therefore we end up with this data set. Okay, we end up with these ranks. Now the difference here in the formula, the D here is just the difference. وش قصدنا بالديفرنس؟ الديفرنس هو 8 rank تاع student 1 in library used 8 ناقص 3. 8 ناقص 3. 8 ناقص 3 will give us, okay, very good, 5. So, and we do the same for the remaining values. All right, Ayman, I'll get back to you. We'll do the same. We'll calculate the difference, but also the formula is not only telling us to calculate the difference, it's telling us the sum of the differences squared. The sum of the differences squared, meaning all of those differences should also be squared. Okay, meaning those differences should also be squared, meaning 5 times 2, it is 25. Okay, and we do the same for the rest. Okay, so we rank the values, and then we calculated the difference, 8 ناقص 3 5, and then we squared the differences. The I is just the values. Ignore the I here. Okay, some formulas they don't write it even without the I. Okay, it's a little bit confusing, but it just means the values. All right, it doesn't mean anything else. So it's just the differences squared. So we have rank for library use minus the rank of grammatical errors. We get the difference, and that difference is squared. We get 25. Okay. When we do everything, we calculate the sum of the differences squared, and that is the first part of the formula, and actually the only part we need to calculate for. Okay, that is the only part of the formula we need to calculate for the sum of the differences squared. مجموع الفوارق ترتيب squared المجاميع تاع differences squared. Okay, or المجموع الوحيد المجموع الكامل تاع كامل levels. In other words, we add up all of these values, 25 plus 2.25 plus 30.25 plus 25 plus 0 plus 4 plus 16 plus 4, it will give us 106.50. Okay, and by then we would have finished the only part of the formula that we need to calculate for, because the rest is given to us by the formula. Okay, the rest is given to us by the formula. All right, let's go back. We say we had a data set for 8 students correlating between library use, frequency, and grammatical errors. Because those values are not truly numerical, at least library use frequency, and because the Spearman correlation assumes that you violated the assumptions for the parametric tests. So the test tries to give numerical values for your non-numerical values. And they do this by, or the test does this by ranking the values. We said we rank the orders from the highest, starting from the highest point to the lowest value, from the highest value to the lowest value. For example, here we have 65 ranked 1 to 8, which is the smallest value is ranked 8. And we do the same here, except we found ties. And we said when we find ties, we continue ranking, but because those are ties, because 3 is not bigger than 3 and it's not bigger than 3, we calculate the means for the 3 ranks that we would have given to those values if they were not tied. So we say 3 plus 4 plus 5 equals 12 divided by 3. It will give us 4. So all of those values will get the rank of 4. Okay. And then we found also another tie. We wouldn't start from 5 because 5 would have been given. 5 would have been given. Okay. 5 would have been given. So we don't use it again. We immediately start because we have 2. We start with 6 plus 7. Okay, 6 plus 7 equals 13 divided by 2. It will give us 6.5. And then we have the lowest value, the smallest value, is ranked 8. We don't start with 7 because we gave here 6.5. We start by the next rank because it's the lowest rank. Okay, so we rank the values. Okay, we follow the formula. We gave each value a rank. Now we're not working by the values given to us by the data. We're working with ranks. Okay. What we do, we need to calculate the difference. The difference for each rank. Minya for 8 minus 3 for the rank of the student 1. 8 minus 3. It will give us 5. And then we square this 5. 5 ولا 5 5 times 5 equals 25, and you do the same. You do the same for the rest. Okay, when we do the same for the rest, we find this. Okay, we divide or we multiply or we square all of the differences. Okay, first we calculate the differences. 4 ناقص 2 2 1 ناقص 5 ناقص 4, and you do all of those. Okay, we don't need the differences. We want the differences squared. We want the differences squared. And then when we calculate the differences squared, we don't need the differences squared themselves. We want the mean. مجموع تاعهم. Okay. Now let's complete our formula. Let's complete this formula. We calculated, as I said, we calculated this part. Now we need to complete the formula. Okay. We need to complete the formula. So we have 6 times, now we have a value for this, 106.5. All right, let me help you. Now, what should we write here? N, this small n. What did we say about the small n at the start? What did we say? Yes, the sample size. Our sample size is what? Our sample size is 8. Excellent. Our sample size is 8. Excellent. 8 times 8, again, n squared minus 1. And now I leave the floor to you to give me the result for this correlation. Okay. Oh, hey, it's yes. Now, very good, very good. Yes, exactly. Yes, it is negative 0.27. It is negative 0.27. It is weak negative relationship, meaning, in other words, there is no relationship. Okay, it's weak relationship. Okay, apparently, students go to the library to chat. They're not really going to the library to do real work. Okay, so let's see how, for example, Hayat Salim found these results. All right, yes, negative 0.27. Yes, exactly. Yes, it's negative 27. All right, so this 6 is the fundamental part of the formula. So 6 times the sum of the differences squared, which is the value that we found by calculating with the data set, so 106.5, divided by 8, multiplied by 8 squared minus 1. Okay, when we do all of the calculations here, 6 times 106, it gives us 639. And then here we have 8 squared minus 1 multiplied by 8, it gives us 504. And then we divide both values. It gives us 1.27. And 1 minus 1.27 gives us negative 0.27, which is, by the standards of the Spearman correlation interpretation table, is here. Okay, it's between 0.20 and 0.29. In this case, we have negative 0.27, which is negative. Okay, it's not positive. If it was positive, it would say that it is negative relationship, weak negative relationship. Okay, this table is important, and the table I mentioned earlier for the Pearson correlation is also important. We cannot interpret the results from our head. Okay, both correlations have their own table. Okay, so you should follow always the Spearman correlation interpretation table, who will interpret the results for you. Okay, so here it is considered a weak relationship. I tried also to plot the results, and we can see a weak relationship. We can see that it is all over the place. Okay, it's all over the place. There is no real relationship when we look at the table here. Okay, because we can see that, for example, this student here went to the library, only goes rarely to the library, but they made only 8 errors. Okay, the same student, another student who goes to the library maybe twice a week or twice a semester, they made maybe 55 or 50 errors, more than 50 errors, which means that grammatical errors are not really related, or they have no relationship whatsoever, or a weak relationship with using library. Perhaps they maybe are related to, but they are not really strongly related to frequency of using the library. Okay, it's not a strong relationship. We cannot really say that there is a relationship. It is moderate relationship, Ayub. If it is 0.50 positive or negative, we say it's a moderate. Depending on the interpretation, Spearman might be more enthusiastic and more positive about it. For the Spearman correlation, if you find 0.50, the Spearman considers it to be a strong relationship. Okay, as you can see in the table here, it is a strong relationship. But when we go to Pearson, Pearson is a little bit stricter in terms of the interpreting the correlation. So for the Pearson correlation, 0.50 to 0.70 are still considered as moderate. Okay, so عندك نفس النتيجة يا أيوب، ولكن كل correlation test يحسبها زي. عندك بيرسون يعتبرها انه moderate correlation، علاقه متوسطه، ولكن سبيرمان correlation بحكم التست بتاعه يقول لك it is strong relationship as you can see by the Spearman table here. I will leave the PowerPoints online so you can see or and interpret for your studies. Okay, and you can also find them in the references here. You can also download the reference if you want. So yes, Spearman correlation would interpret point 50, like you see here, as strong relationship. Okay, there is we don't say Ayub, a real relationship or a fake relationship. We just say strong, moderate, or weak. Okay, so you have to use this vocabulary. You have to use the vocabulary strong, very strong, strong, moderate, weak, or no, or negligible relationship, or weak relationship, very weak relationship. We don't say real or fake. Okay, and I'll say we can only say the strength of the relationship and the direction of the relationship. Okay. Yes, exactly, Ayman. It's not non-linear association. It's not really linear. Yes, weak negative correlation. Yeah. This is it about the introduction. What matters for me is the concepts and the differences between the Spearman and the Spearman correlation and the Pearson and the Spearman correlation and the conditions for those tests. And also we can see what's happening in the background in those tests. We can see what these programs are calculating in the background. And I'm really happy that some of you are following, and I hope it was not overwhelming. Okay, I hope it was not overwhelming for some of you, because I know it can get really overwhelming given given the nature of the module. Let me just check the. Yes, if you have any questions, you are more than welcome to ask. Okay. Yes. Yes. Overall, I just want to know your opinion about this lecture and about the concept of correlation. Or was it difficult? Was it easy? What do you think about it? So to use Pearson normal distribution must be good. Yes, in general, yes. You would want a normal distribution for both data. Yes, for both variables. Yes, exactly. Yes, for both variables. Muqrani, Muhammad Akram. It was a bit difficult. Yes, a bit difficult for me. It was clear, Ilya. Yes. Okay, Pearson better than yeah, better than okay, now I think I understand why I like each other very much. Yes, exactly. Yeah, perhaps. Yeah. As I said, Pearson is a little bit stricter. Okay, it's apparent from the formula. They did not like each other. They did not get along, which is funny. Yes. Yes, exactly. Yes. I think more attention to details. Okay. Usually, perhaps you're with more than two variables in a correlation. Fatima, yes, but I'm not gonna go to that far. We can do correlation between more than two variables. It is called the multiple regression, but I'm not gonna go to multiple regression because I think this is the limit. Okay, I think I'm already even stretching it now. Believe me, there is way more stuff. We did not even scratch the surface of statistics in the field of applied linguistics. Okay, this is not something foreign to applied linguistics or linguistics. We're doing something that is now fundamental. If you want to say I have a degree and I want to be a researcher in the field of applied linguistics, this is fundamental. This is needed. We can correlate between multiple variables, more than two variables. It is called the multiple linear regression, but I'm not going to go to it. I think it is. That's why a little bit. No, 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 no. Has nothing to do with being adabi or ilmi or you did. Believe me, you did much more difficult mathematics in your third year as a literacy. This is a kappa. This is a fake justification. Okay, I know what they do in mathematics in adabi. No, this is هذه في الجزائر هذه fake reason. No, it's not. If you did languages or philosophy, literature and philosophy, does not mean you cannot understand statistics. Does not. Statistics is primarily an applied branch of mathematics. It's not mathematics. Okay, it's nothing to do with mathematics. It's way, way, way easier than mathematics. Because our benefit, I think we have to test a correlation parameter. Yeah, exactly. It requires attention to details. I think it requires attention to details. Okay, statistics as a field, as a practice in research, it is not something that you listen to or just gloss over or you just read and have the general idea. You need to pay attention to details. You need to do your assessment of assumptions carefully, and you need to make careful decisions. Okay, in order not to get wrong results. Okay. I was hoping we can move to better things like effect size and multiple regression and stuff like that, but perhaps we can do those in extracurricular activities, maybe in the second semester, because believe me, the field of statistics and the field of quantitative data analysis is advancing a lot. And now this is important. Why? It's important for you in your work as teachers before being researchers, because you can do many interesting things. And also, even if you're not teaching any other field, you require to do some of these calculations. And also, if you're going to be a researcher, if you're going to proceed, inshallah, to doing a PhD, to something else, statistics is important because it will allow you to read papers, read really advanced papers, not shallow papers. Okay, you will be able to assess the quality of good papers, good research papers in well reputable journals. Believe me, it makes a huge difference when you read papers. You know, when you look at a paper on in your field and then find a table and statistics and you cannot read it or interpret it, it can be challenging. It can be challenging, and you can stagnate. Okay, but when you know the basic statistics, when you read a paper, you'll be able to interpret the results and understand exactly what the paper is saying. Okay, this is not just about calculations and making it difficult. We're not trying to make things difficult for you. We're trying to give you something that is really needed. Okay, believe me, ask anyone who did a PhD or who went to study abroad or who's doing any serious research work, and they will tell you the importance of statistics in the field, in our field, applied linguistics in general. Okay, sociolinguistics, psycholinguistics, didactics, any field, phonology, any field. Other types of correlation besides causation. Types of correlation besides causation. Correlation does not assess causation. Besides causation, you mean what are other types of correlation besides causation? Your question is wrong, Khalfa. Your question is wrong. Other types, the other type of correlation is multiple regression, but it's a whole other chapter. A whole other chapter. I think for your lecture this year, I'm gonna stop here with concepts. Starting next week, we will be doing general revision and practice until your exams.